Hello everyone, welcome to the past paper discussion. We are in third question of the series and it's quite an interesting one based on calculus, integration, maximum derivatives, all those stuffs are included. So let's get started. Here we can see a diagram over here and so we can clearly see it's bounded with x-axis, y-axis and another line parallel to y-axis, that is DC, and one particular curve is also there. That curve is modeled by the function f of x is equal to minus x square by 50 plus 2x plus 30 from the interval 0 to 70. X ranges from 0 to 70. So this is given and multiple questions involved. It carries around 17 marks and stay tuned till the end and you will get a lot of things and tips and tricks, right? So first one, for this f of x, find the derivative f dash of x. It's quite simple. Minus 1 by 50. So f of x, let's write in this way, minus 1 by 50 x square plus 2x plus 30. What is x square differentiation? Any differentiation like d by dx of x power n, your variable in the base and some number in the exponent. This will be followed, correct? So it will be n into x power n minus 1. Same thing. So minus 150, 2 into x power 2 minus 1 plus 2 into, when you differentiate x itself, it becomes 1. Plus 30 will become 0. Any constant, if you differentiate, it will become 0. So you will get, and you just simplify it, x by 25 plus 2. This is my f dash of x. Actually, our f dash starts from here itself. So that's it. We got f dash of x. That's simple. Now, moving forward, we have to find a point on the field which is farthest from the north, which is the furthest north. So what they mean, this is the field, this is the north direction. So which is farthest north, this curve will have a maximum, right? That maximum point, it's not C. We can clearly see that. So we need to find maximum of this curve, and that curve is modeled by f of x. But here we can't directly go with graphing f of x and finding maximum. They have clearly mentioned find f dash of x, hence find the maximum of the graph. So we need to go algebraically, hence find. So that's why, how will you find maximum or minimum points? Equating f dash of x to 0, we have that. Let's do x by 25 plus 2 equals 0. Minus x by 25. I missed the minus over here. So minus x by 25 plus 2 equals 0. What is x? Minus x is equal to minus x by 25 equals minus 2, and this will give you x is positive 50. So x is 50. Maximum means I need the y value also. For y, you have to consider f of x. Any point on the curve is modeled by x comma f of x. That is, y is your f of x. So my f of x is minus x square by 50 plus, let me check it, 2x plus 30. And I know what is my x. I can just substitute over there. It's 50, right? So minus 50 square by 50. You can solve it calculator too, but I'm just solving here. So 150, 50 will get cancelled. 130, 130 minus 50. Finally, y value is 80. And we got the coordinates. The furthest point towards the north is x is 50, y is 80. Is the furthest north point in the furthest north. Right? That's simple. Now, moving forward. So first two part is very simple based on differentiation and simple solving. Now point A has coordinate 0, 0, B has 0, 30, C has 0, 32, D has 70, 0. Write down the integral which can be used to find the area of the shaded region. We can see the shaded region which is named as R. To find this, what is the area of the integral? this comes under area of the region enclosed by the x-axis, and the curve is above, that is above the x-axis, not the below, right? So this is the condition. This is available in our formula booklet, and A is equal to integral A to B y dx. A is lower bound, B is upper bound. So this curve ends at 0, starts at 0 and ends at this side at 70, because C is 70, 72. So that's why we are clear with the bounds. So area for the integral for the region is integral from 0 to 70. Okay, actually what we will be doing, we will just split that into rectangles, and we are splitting it across x so that it's from 0 to 70. And what is the function? Y dx. We have y. Y is nothing but f of x. We have that given, which is minus x square by 50 plus 2x plus 30, most importantly dx. So we have to write down the integral to find the area of the shaded region. Find the area of the Linda's field. Okay, we have the integral, so we can just use the calculator and solve for this. Okay, right. Now moving to the calculator page to find the area. Go for calculate. Let me define my function here. For defining, you name the f of x and control, and this semicolon and equal you can put, and my function goes like this. Minus x square by 50 plus 2x plus 30. So once you define the function, it's done. Now I'm gonna integrate it. So go for this. We have a lot of functions. So pick the integral with the limits. It runs from 0 to 70. I'm integrating my f of x with respect to x dx. That's it. You click enter, you got this 4713.33. That's simple. We found the area. Now moving to the solution page. The area is this, right? So area of the Linda's field is this much, 4713.33. When you make it to 3 significant figures, 4710 meters square. This is the area of Linda's field, right? And that's simple it is. Now, this actually carries 4 marks. See how simple, right? So now, okay, Linda has used, we have solved using GDC, right? Linda used the trapezoidal rule with 10 intervals to estimate the area. So this calculation underestimated the area by 11.4 meters square. So actually we know original area, right? Almost the perfect approximate, 4710. But she did trapezoidal rule and she got some error. It was underestimated by 11.4. Like we don't know what she got, but the difference between the actual value and the approximate value by the trapezoidal is 11.4. And this is the percentage error formula. Value actual minus value, approximate value minus exact value divided by V of E. So it's a modulus. Since there might be the case increase or decrease, that's why modulus times 100%. Now here we don't have VA and VE. We directly have that 11.4 is underestimated, right? So that is 11.4 is the difference. They have clearly mentioned it, divided by exact value. We have just solved it, 4710, or you can, for the more perfect answer, you can use 4713.33 also. But let me take like this, times 100%. So here we should be careful, or we will spend more time here. Okay, what is 11.4? Is it 4710 minus 11.4? No. So that underestimation cannot be that much. So that they have given actually the difference in the values. And just simplify this using calculator. You will get, let's cancel the 0, and this 10 will get multiplied, 114 by 471. That's a simple calculation. You will get 0.24203. Most importantly, your answer through this formula, it's a percent, right? So don't put it's 24%, right? So it's 0.242% when you opt for three significant figures. That's the percentage error, right? That's simple. Now, moving to the next part. Okay, in the same part, actually, second question. Suggest how Linda might be able to reduce the error whilst still using the trapezoidal rule. Okay, she's gonna rely on the same trapezoidal rule, but how can we reduce this error? 0.242 is kind of large percentage error, right? So how to reduce it? Let's understand trapezoidal rule work. So we will split this into different intervals, and she did 10 intervals like this, and she make the trapezoids instead of the rectangles usually we will do. So you want more accurate result, means more thin trapezoids we should make, right? So 10, you make it 100, it will be a better estimate. You make 1,000, you make 10,000. So basically, I should increase the number of trapezoids, correct? And also I can say like number of intervals, subdivisions, like the intervals is 10, make it 1,000. That's what it means. If I increase the number of trapezoid, it means mathematically increase the number of intervals, that is the subdivision, the approximation become more accurate here, right? And that's a simple suggestion. We can give it in our own words, but with a little mathematical touch. So suggestion is increase the number of intervals. Simply you can give that, so that the approximation will be more accurate than this, correct? Now moving to the next part. It's quite different, but the same description and land area we have. Linda would like to construct a building on her field. The square foundation of the building EFGH is given here. Will be located such that EH is on the southern boundary. On southern boundary, EH is given over there. Okay, so the next part. Here, Linda would like to construct a building on her field. The square foundation of the building EFGH will be located such that EH is on the southern boundary of a point. So we can see here EH is on the southern boundary. And point F is on the northern boundary. Northern boundary is a kind of a curve. Point F is here. It's a model they have given. A possible location of the foundation for this building is shown. This is just a possible, one of the possibility, but we need to work. The area of the square foundation will be the largest when GH lies on CD. So to make the foundation big, this GH should overlap with CD, right? So in that case, it will become, of course, F will get moved, right? So F also will get moved, and I will get a bigger square foundation, and it still should be a square. These are the things given. Now, using this description, all the things in mind, we have to go with the question. What is D? Find x coordinate of point E of the largest area of the square foundation. So for that largest foundation of square, what is x coordinate of E? And then we have to find the largest area of the foundation, the maximum square foundation that can be laid over there. Correct? So I hope this might be clear. Now let's move. Okay, so as they have mentioned, let me draw this possible. Let's think, okay, so this should be like this. GH, you just move the GH over here. I can't take till this. It seems like you can take, but yeah, it seems like it's not that much. So just a random figure. We can just make GH. So now if I make it over here, it seems like better, like have a bigger area. So the F is here, but I don't know what is this point. So let it be X. And I know this 70, right? So this is the thing we have did. Find X coordinate of E. So this is your X means like from 0 to this point, it's X. What is this value? The biggest square. Actually, we are solving on this square. We are going to work for this square only. So the square's side length can be calculated as 70 minus X. Right? Okay. So the width is or the length you can mark 70 minus X as of now. Now the length is, if I take this the lengthier part, it is nothing but y coordinate of this point F. I don't know X, let it be X. So F of X will be the length. So the length is F of X. What is F of X? Actually, this is given, right? The curve's equation is minus x squared by 50 plus 2x plus 50. So that's it. Your length is this. Your width is this. And since it's a square, length and width will be same. Now you can equate this because in a square, length and width are same. And then you can find the particular x value. This will complete first part in D, right? And it's quite simple. We can just solve it using calculator. Minus x squared by 50 plus 2x plus 50 equals 70 minus 6. Why I'm equating? Since it's a square. Which is a square? EFGH is a square. And we need to switch to the equation that is graphical solving. GDC. Okay, let it be f of x. I need to equate for algebra numerical solve. Your f of x is there actually equal to the width. F of x equals, what is the width? 70 minus x, and we are looking for solving for x. That's it. I got 14.98 and that's it. We can just take it. If you approximate, it's 14.8 or something. So we got the x coordinate. So this implies I got it from the GDC, which says x is equal to 14.792 and x is equal to 14.8. Let's fix it. Correct. So that's simple. And find the largest area. You know x now. So that means you know length and width. So just width is enough. It's a square, right? So to find the largest area, this is the possible x value that can make the largest area. So largest area, let me make it side into side. So 70 minus x times 70 minus x. That is the side. That's a simple one. So 70 minus 14.8 the whole square. This is a simple calculation. Subtract and square it. You will get it around 3047.92. Meter square. And three significant figures, or like when you round it off, it's around 3050 meters square. This is the largest area that's possible in this case. And that simple it is. So in this question, we can easily get 17 marks with all A1 grade. That simple it is. And stay tuned for the next video. Thank you so much for listening with us. Keep learning.